Well, hey there, kiddos. Here is your video over dividing exponents. So now we're going to talk about, we've talked about negative exponents, we've talked about multiplying with exponents, now we're going to talk about dividing with exponents. So we're going to start with this property, which is the quotient of powers. So it's when you have the same base being divided. And so when that happens, you keep the base and you subtract your exponents. So it's just like the fraction bar is a giant minus sign, so you will subtract the exponents. Just like when we multiply two things with the same base, we end up adding their exponents. It's an opposite operation. So division is the opposite of multiplying and subtraction is the opposite of adding. So we just do the opposite of what we did before. So let's do some practice problems. So this one right here, I have x to the 7th over x squared. And if I'm going to do that, what I have to do is I have to keep my base, which is x, subtract the exponents. 7 minus 2 becomes x to the 5th. And now this one, I know there's a negative exponent here, so whenever you are trying to simplify things that involve negative exponents, if you can use some other property like multiplication or division property first, do that and then see if you have any negative exponents left. So this is going to become, keep your base x to the 2 minus negative 3, because you have to subtract the exponents and this 3 has a negative. Well, if you remember your integer rules from junior high, when you have minus a negative, they cancel each other out and make a plus, and so this becomes 2 plus 3, which is also x to the 5th, just like the one we had above. Now, I think that we have talked about this rule. I think we talked about it when we did multiplication, but just in case, we're going to review. And so the power of a quotient is when you have a fraction or a division problem all to a power. When you have this kind of problem, it's just like with the multiplication, and you will distribute your exponent to everything inside the quotient and then simplify if you can. So you just distribute the exponent to each part, and I'm pretty certain we talked about this, but we're going to do one example just to be sure. So this 3 outside has to get distributed to every single thing in parentheses, the 2 included. So you end up with 2 to the 3rd, x to the 3rd, over y to the 3rd. Well, 2 to the 3rd is the same thing as 8. So this is like having 8x to the 3rd over y to the 3rd. So let's do a few more practice problems just to make sure we have this down. You're going to find that we are going to combine rules. You're going to have some multiplication properties in here. You're going to see your division properties. It's all going to start to gel together, come together. So number 1 here, they have the same base. The base is a 3. I will subtract my exponents. 8 minus 2 is 6. Now for number 2, my base is an x, but I have these coefficients. I have this negative 3 over 15. Well, they don't divide. Negative 3 over 15 does not divide into a nice pretty whole number, but it will simplify as a fraction. So if I take negative 3 over 15, I can divide both of these by 3. It becomes negative 1/5. All I did was reduce or simplify that fraction right there. Then you will keep your base and subtract your exponents. Well, 7 minus 3 is 4. Sometimes you might also see it written like this, so the x to the 4th, since it's positive, will stay in the numerator, so it'll become negative x to the 4th because of that negative 1 over 5. These are the same thing. It just depends on who's writing the question and how they're expecting it to be seen, but these mean the same thing, just so you know. So number 3, keep your base. 2 minus 5, though, happens to make a negative 3. And if you remember our rules about negative exponents, I have to rewrite this so that the part with the negative exponent moves down here to the denominator. So the 1 stays in the numerator, and the x to the negative 3 moves to the bottom, so it's x to the positive 3. So 4 and 5 are one of those where I have to take the exponent outside and distribute it to everything inside. So that's what we're going to do. It will have to distribute to the 2 and to the x, and it will also have to distribute to the y and the z. So I'm going to end up with 2 to the 3rd power. When I distribute my x to the 3rd, I multiply, so this becomes 3 times 3 makes x to the 9th. And then in my denominator, I have y to the 3rd, z to the 3rd. And then we talked already, 2 to the 3rd power is 8. So this is 8x to the 9th power over y to the 3rd, z to the 3rd. So pause for just a second, see if you can do number 5 by distributing your exponent to everything inside, and then come back and check your work. So you distribute your exponents of 5 to everything, so you end up with a to the 5th, b to the 20th, because 4 times 5 is 20, over c to the 10th, and d to the 15th. So there's your simplified. You can't go any further than that because none of these are like bases. Nothing looks the same. So let's do a few more. So number 6 and number 7 are multiple choice questions. We're going to simplify it and then find the one that matches. So we're going to go one base at a time. So I have a to the 4th over a to the 3rd. So I'll subtract 4 minus 3 is 1. So that becomes a to the 1st, or just a. For the b's, I'll subtract those exponents. 2 minus 5 becomes negative 3. And then for the c's, remember there's an invisible 1 right here. So I'll do 1 minus 2, which makes negative 1. So I've got negative exponents here, these two. So if I put this all over 1, I'm going to have to move that part to the denominator. So the a will stay on the numerator. Then you have b to the 3rd, c in the denominator. And if you look, that's answer choice D. So let's do number 7. We're going to divide first. 27 divided by 3 happens to be 9. Then I will go ahead and subtract, go one base at a time. My x's, I have negative 2 minus 5. Please be careful when you've got negative exponents already. Negative 2 minus 5 makes negative 7. You can double check that on your calculator just to be sure. Your y's, 6 minus 2 becomes 4. And the z to the 0 down here in the numerator just becomes a 1, so it's just going to cancel itself out. Well, now if all of this is over 1, this right here has a negative exponent, so it has to move to the denominator. So the 9 and the y to the 4th stay up in the numerator because they have positive exponents already. And then the x to the 7th goes to the bottom. Remember, the z dropped off, so it looks like my answer is C. So now let's put this to use. So I have the area of a rectangle is 10x to the 6th y to the 4th square units. If the width of the rectangle is 5x squared y squared, what's the rectangle's length? So they've already given you the area and one of the dimensions. This is automatically a division problem because if you remember, area is length times width. Well, they're asking you for the length, which means I have to divide both sides by the width to get the length. So it's a division problem. So I'm going to take my area, 10 x to the 6th, y to the 4th. I'm going to divide it by my width, which is 5x squared, y squared. And I'm going to go ahead and 10 divided by 5 is 2. When I do my x's, 6 minus 2 is 4. And when I do my y's, 4 minus 2 is 2. This is the length of the rectangle. So number 9, it's another problem. So the area of the rectangle below is 40x cubed y. What's the height? So they're asking for this measurement right here. Well, again, I'm going to take my area, 40x cubed y, and I'm going to have to divide it by the other dimension they've given me, which is 10xy. Well, division, 40 divided by 10 is 4. When I do my x's, 3 minus 1 becomes x squared. And when I do my y's, y to the 1st over y to the 1st, well, they just cancel each other out. So there is no y left. So you just end up with 4x squared is the height of that rectangle. So that is how we go about dividing exponents. You just divide coefficients or simplify them if you can, and then subtract exponents. That's all there is to it. We'll practice this tomorrow. I hope y'all have had a great weekend, and I will see you tomorrow.